Anyway, good afternoon, everybody. Thank you very much for spending your time with me on this glorious Friday afternoon. I know it's hard to get away when you got good weather, but thank you so much. So today's webinar is going to be about Bitcoins and blockchain technology in today's economy. You're probably hearing a lot of news every day about the price of Bitcoin rising it's exponentially. So there's a lot of interest, and plus there's a lot more happening in the world in terms of large corporations investing money into blockchain technology. So you probably need to understand what it is that is drawing all these large institutions when before it was literally unheard of for so many years. So with that, let me start. And I want to start with first there's a book that is called The Tipping Point by Malcolm Gladwell. Has anybody ever read that or know anything about that?
No.
I guess not. Okay, so basically this is a very interesting book. It was written in about 2000, and he says when you start a trend and it starts to spread like wildfire, or you create a product and it becomes a must-have item, you create a social epidemic. And it's like a virus. So the tipping point explains how social epidemics, spreading ideas, messages, behaviors, and products multiplies like a virus, and it keeps growing and growing until bang, you get this boom and explodes, and everybody starts to use it. And that's when you have full adoption. So we're on the verge of reaching such a tipping point in Bitcoin and blockchain technology. It's important to understand this technology, the implications, and why such a tipping point is about to happen. This webinar hopes to touch on these aspects and show you, what's happening currently and where you'll start seeing the changes coming rapidly. So it was a long time back. It may have heard in the news that when Bitcoin came out, it was around about 2009. I mean, didn't have a lot of valuation perhaps at that time. And now the people who did these transactions must be regretting it. So the guy who spent 10,000 Bitcoins to buy two pizzas must be kicking himself, or the person who lost their hard drive because it had Bitcoins on it must be kicking themselves too, because today's value of one Bitcoin is worth, well, as of yesterday, it was $56,456.40 yesterday afternoon. So, that's a lot of money that somebody's lost because of not having held on to them. So, anyway, the news keeps coming about the price of Bitcoin. So it's definitely hitting the news. It's definitely starting to pique people's attention as to, what is this thing? I need to know something about it. And I hope today's little session will give you a little bit more insight and understand not just Bitcoin, but what's behind it. And even more important, there's a thing called smart contracts, which are a lead on based on the technology that's being used. So, when you in Bitcoins, people just like you have bank accounts, you're going to have this weird number called a Bitcoin wallet, which is these 32 weird characters that when you want to send money to somebody, you use this. Nobody's going to remember this or be able to punch it in. So generally speaking, use the little QR code thing. So you go and you scan this and the number automatically is entered. So that's when you send Bitcoin to somebody else. This is generally the practice you will use, right? So I'll try and explain a lot about the way Bitcoins are transferred in the coming slides. So, say an example is, say you have Alice in Vancouver and Bob's in Toronto, and you want to send some money to them. You want to transfer that money in a safe way, and in a way that you can also keep track of where that money came from, went to, and how much. So I'm going to let you imagine, or imagine for a moment, the blue box is going to be what's called the blockchain network, and in terms of real ideas that you can relate to. So it's not blockchain per se, but the idea is there, the concept. So let's say, you want to send money, so maybe put it into, send it with Brinks map the security people, and they will transport this money bag, put it in their vehicle and transport that across to Toronto. And it's a secure transfer network because Brinks has been around for years, and of course, they don't lose money, and they have armed guards and all the other things, and they keep track of their vehicles. So there's a secure way of sending money across. So the Brinks map vehicle plus the road network that you use, you can think of that as the blockchain network. Bitcoins is the currency. The network is how you get the currency one place to another. So in this case, we're using a transport vehicle and the road network or rail network or air network to get it to your destination. So that's how we can think of it conventionally. So when the vehicle arrives in Toronto, we hand it across, and eventually the money gets into Bob's hands, and that's the end of the transfer. So that was just a simple example of, when we think conventionally of how money is transferred. So now what I wanted to kind of touch on is just go back a little bit and figure out what is this Bitcoin. The Bitcoin came about in 2008 when this Japanese guy or a group of people wrote a white paper in 2008 called Bitcoin, a peer-to-peer electronic cash system. So his idea was that if you use this electronic cash mechanism, you could send payments from Bob to Alice to Bob, or Bob to Alice, without going through a financial institution. And so when you do that, there are lots of advantages. One of them being that it's faster. The other thing is the fees are dramatically reduced. And so those are like key benefits of being able to transfer money electronically without some intervening party. So the birth of Bitcoins came in 2009 after the white paper came about. And so one of the side things that, just a side note on this, is that because to honor the founder, the Satoshi is a unit of the Bitcoin cryptocurrency, just like we have pennies and dollars. Pennies were the lowest unit of currency in Bitcoin world. Satoshi is the smallest unit of currency. And right now, right below, it says 100 million Satoshis equals one Bitcoin. All right, so that kind of just gives you a lead into what Bitcoins are. And so, but the other side of the thing is, I was going to say the other side of the coin, but the other important one to note is there's another digital currency called Ethereum. And the nice thing about this is the co-founder was a Russian Canadian called Vitalik Buterin. And he studied at the University of Waterloo, and he's became a co-founder for this other coin called Ethereum. So he wrote this paper in 2013, and what he was to build on the idea behind Bitcoin, but make it even better. And one of the things that he was trying to do that wasn't possible with Bitcoin easily was being able to have this thing called smart contracts. And I'll talk about smart contracts later, but smart contracts is where you're able to not just do the transfer of funds from A to B, but in the message that you're sending to do the transfer, you add a snippet of code in there. And as it goes across the network, this code gets executed, and it's part of the requirement for doing a smart contract. So I don't want to confuse you right now, but just note that the difference between Bitcoins and Ethereum is that Ethereum has the ability and the flexibility to carry code with it that can be executed along the way, and it makes it a lot more flexible to do other applications. And this is where smart contracts is where the business world is really keenly interested in developing and adopting in their business world. So that's kind of the lead into that. Now, maybe if you've seen anything on in the web, you'll see that there's about 2,000 different currencies out there, cryptocurrencies, and too many to actually even talk about in this thing. But I just want you to be aware that there's over 2,000 currencies is in there. One of the other ones that may be of importance is Ripple. Ripple is one that the banks are starting to think about because it allows bank-to-bank kind of transfers to take place. And you'll see, and the reason I'm talking about banks is if you go back in history, maybe 10, 15 years back, a great thing was that like Switzerland was, and Austria and, the Cayman Islands were all famous for having tax havens where, people used to park their money, people who had lots of money. Switzerland was one of the best known because it had the concept of numbered Swiss accounts where, the identity of the person was unknown. It's just a number and you had, lots of money in there. And Switzerland were proud that they would say that their secrecy and privacy was, second to none. Nobody could do anything to get the information. So people felt very secure until the US government stepped in and wanted to know all the US account holders who were holding secret numbered accounts, right? And Switzerland refused. Of course, they tried to push back on the US government. However, there's one thing that all banks need is a network to send transfers between each bank. So this is not in the public domain, but behind every bank, they have a thing called like a SWIFT network. I think it stands for Society for Worldwide Interbank Fund Transfer. So this is a network that connects all big banks together. And if you are a bank of any standing, you had to be able to do the transfers between other banks. So the US government told Switzerland that, unless you give us all these numbers, we're going to pull the plug on you. You can't use the SWIFT network. And therefore, once you stop using SWIFT network, you're out of the game, right? So that's how their hands were forced to reveal account holders in Switzerland. So that just tells you that, the privacy aspect of it, you can't be guaranteed in our present banking system. So anyway, let's just kind of give you a little bit of history there. But so one of the things we have to try and understand is that, our existing internet is really used for pushing data around. So, when you go to a website and you go on Google, you search for something, you get information back. So that's internet is made for the currency of the internet is data, and so and in blockchain world, which is what we're going to be using for Bitcoin, the currency of transactions is transactions itself. So what we're doing is moving things of value between one place and another. And that's the big difference between internet and blockchain. So one is about value and the other one is about data. And the other difference is it's called a client-server network in the internet world because generally when you put a query in, let's say in a Google search, that data, that request goes to some server somewhere in the cloud and the information comes back to you. So you are the client when you make that request through your browser. And when the data is pushed back to you from somewhere, it's coming from a server. And that's called a client-server network. Whereas in blockchain, we'll come to see is based on a peer-to-peer network. In other words, there's not one central place. It's all distributed all over in that network. And you'll see a lot more clearer examples of that as we go on. Okay, so I'm just going to move to the next slide. So let's try and do a little bit of a comparison between our existing financial system and see what the weaknesses are and why now there's a shift towards using a digital currency system. So in an existing banking world, we have to trust by authority. In other words, we trust our banks. We trust our TD America, TD Canada Trust, BMO Bank or CIBC. We trust them to handle our money, maintain the balances, and all that kind of thing that we expect for handling and managing our money. And because of that, it's called a centralized authority. And so even now, though, in this day and age, if you want to do a wire transfer anywhere, it still takes 3 days. And with all this technology around, it takes 3 days. That's pretty slow. Plus, the hefty fees. I know it's something of 30 to 50 bucks for doing a wire transfer of any size. And so that's, a big drawback. One of the other things is private ledger. All the information the banks keep is kept by themselves. So you only get to see the statement for yourself, but you don't know what else is going on in their banks. And as you know, most people every month get a little fee tapped onto their statement, and that's the fees that they charge either per transaction or for any other special things if you use Interact, wire transfers, or take out a loan or that. These are fees that the banks make their profits from, and you're paying that for the privilege of having those services. So although the banks do have fair security, it's not perfect. You still hear about banks, having your accounts being hacked and your numbers being stolen, and you don't know for sure if somebody's misused your account or it gets locked out. So there's no really account privacy. Even you get your monthly statements. I mean, that people raid your mailbox, they can take that statement and, use that for some other malicious activities. And last thing is, many people are credit cards. So businesses that rely on having credit cards for making their sales, I mean, they lose money sometimes because people do chargebacks. It used to be a thing where, some consumers, they'd order something online and then they say they never received it, and then they do a chargeback. And so they keep the product as well as, not having to pay for it. So these are the kind of the drawbacks of our present system. So if we move to a digital currency system, the trust now shifts from one central body or authority to trust by consensus, where people within that network, 50% or more, decide on whether this is a trusted transaction or not. And I'll show you that in more detail. So probably not as clear right now, but just make a note of that mentally. And so the thing is, it means that it's a decentralized authority. So it's not one person or one body that's managing that trust and the management of your funds. It's a whole bunch of people. And again, the speed is fast because we're doing everything electronically now. And the difference between the banks and digital currency is this open ledger. Open ledger means that all transactions are public. Nobody's hiding their transactions. And you might think, oh, well, You know, I don't want to know. I don't want to know, or anybody to know that I just sent 50 bitcoins to somebody. So there's a way that it's open. It means everyone can see the transaction, but they don't know who it's from. So we'll cover that in a little example later. So as a result of trying to do everything electronically, the fees are very, very low, which means reducing cost of transactions. Cost of doing business is what you're trying to reduce. And so you can reduce your company expenses, you make bigger profits, right? And that goes with everything in business. And the other thing is because we're doing this with some special cryptographic technologies, it's very, very high security. And so it will be tamper proof. In other words, somebody can't later say that I didn't do this, or, somebody changed the amount. So instead of sending $20 to somebody, somebody altered it and made it $25 electronically. We'll show that that's not possible. And then we got account privacy. And this is going back to having an open ledger, but still having account privacy. They seem contradictory, but I'll show you that it's possible. And non-repudiation just means that you can't deny a transaction once it's made. And this is the great thing about digital currency system, that, once the transaction's done, that's it. No changes whatsoever. And so instead of taking 3 days for wire transfers, we can do it in a matter of, short, maybe 20, 30 minutes at the maximum. So all this means that trust is very paramount in any kind of technology where you're shifting money or anything of value around. So let's. So we've said that trusted parties are in any transactional system. It doesn't have to be banks, but you have always, in our conventional system, you have always somebody that you trust. So whether you're buying a house or creating a contract, when you buy houses, you rely on your realtors to create a contract that binds the buyer and seller together. When you're dealing with banks, of course, it's your bank branch and their management that take care of your account information. And then when it comes to contracts, we currently have lawyers. So we put our trust in the lawyers to make sure that they are, honest and have good integrity, and ensure that the contract that we sign, that they've vetted it, made sure everything is good. And of course, we don't get liable for something later on, and we clearly understand what the terms of that contract is. So in the blockchain world, trust is granted by virtue of a consensus mechanism. So that's basically, a decision made by a majority of the people. And when you have a majority, which is over 50%, everybody can agree that this is okay, that we trust this transaction is okay. And that's how we show consensus. So in this blockchain world, this consensus mechanism is very important. And there's a thing called proof of work in the Bitcoin blockchain. And it's basically this proof of work is some way of carrying out some mathematical calculation, which allows you to confirm that the transaction is valid. And then if the transaction is valid, only then you add it to the ledger. And I'll show you that the ledger is like an open ledger, but it doesn't just get added automatically when you make a transaction. You have to have it validated first. And that validation process is through this proof of work. So why do all these people in the blockchain network do this proof of work? It's because whoever does this work will be rewarded with some fee, a small fee in terms of Bitcoins that makes it worthwhile for them to spend their time and energy. So I alluded to the fact that contracts smart contracts are things that are coming into our, important into an important time in our era. So Bitcoin contracts allow you to do multi-signature accounts, and you can have a smart contract that allow for multiple signatures to agree on some activity, and you can make agreements between a lot of different companies, example, and you provide a utility of other contracts, and then also trigger the sending and receipt of data to applications. So what that means is that you have a contract that if something happens and something is fulfilled, it will trigger another event. So it's like an automatic carryover. Only the next part of the contract is executed on the condition of previous terms being met. Okay. So the application of smart contract, why is this important? Well, the government voting system, I mean, it wasn't too far back that we saw the US government in turmoil about their voting system, and Mr. Trump alluding to the fact that there were fraudulent activities. But if you introduce smart contracts into a voting system, that kind of thing could never happen. Neither could somebody ever say that it was tampered with, because this is one of the things that they should be able to overcome. Your healthcare system, medical records, sensitive records are maintained currently, in area and storage, but blockchain can really help encode and securely health records of patients, so it doesn't get tampered with, it doesn't get misused by anybody or hacked. So that's a key area of smart contracts that it will start to grow. And the other thing is, in businesses, we're concerned with supply chain management. So how, let's say, for example, you're a car dealer, or your car manufacturer. From the time a car leaves the factory, you assign a VIN code to it, and that VIN code is carried for the life of the car. But if you record transactions as the VIN code changes, you can attach the owner's name and address to that VIN code. So when you buy it from the showroom, the VIN code transfers from the dealer's name to your name, and when you sell it to somebody, it goes across. So you have what's kind of an open ledger where the history of that car can be maintained. And that supply chain management will apply to different areas of industry, and lots and lots of different use cases for that. And of course, financial services, we could talk about insurance and anything where you're transferring funds, even the stock exchange is definitely an area where smart contracts may start coming into play in the coming years. Any questions so far before I go further? Is there anybody? Hopefully I haven't lost anybody. Okay, so I'm going to just talk about how do we have a simple way to transfer Bitcoins from one person to another. So when we need to have a way where we can electronically send a message that contains the relevant information for a transaction to be recorded. So first thing is we need to know who the sender is, and then who the receiver is going to be, and then the amount. What I haven't shown here is a timestamp, because every time you do a transaction, you need to, of course, record the date and time when it occurred. So I'm not showing that just to make things a little bit clearer here. And so every time you do this, you'll record that transaction. And this is the start of a ledger. Here is a sample ledger, which actually does show the date and timestamp. So you can see, 9:25, 9:26, 9:27, all the way to 9:35, recorded some transactions with the sender and the receiver, and the amount are recorded. In the blockchain world, a block will be transactions that you've kind of grouped together over 10 minutes and validated them. And they may have a block number, right? Let's say, for example, it's block 233 was in this time span from 9:25 to 9:35, a 10-minute. And and these are the transactions that are recorded, and they get validated. So that is what a ledger might look like in an open ledger looks like. It's for everybody to see. However, we didn't cover the aspect of hiding the identity of the sender and the receiver. So instead of using the name Bob and Alice, we'll be using the Bitcoin wallet address, which is that 32 character number that you can't fathom out, but it's like your account number. Okay, so all you will see is these numbers that are showing the sender, receiver, and the amount. And so your identity is hidden. Although everything is clear for everybody to see, nobody can make out that it's you or Alice or Fred or whoever. So what do we need in a blockchain? So a couple of things we said are important. It has to be trusted, right? So we've said that consensus is important, and it's a way in blockchain technology where at least 50% of the nodes check that the block is valid, and it can be added into the ledger. So it doesn't get added onto this ledger until everybody had a chance to validate it and more than 50% agree on it. Okay, so people can't send invalid transactions because it'll be rejected by the other people. We said it's decentralized because the computers in this blockchain network, they're all, everybody who has a blockchain mining computer will be coming up and doing their calculations to come up with this validation, and it's like a true or a false. So if and this, because it's not based on the person using that computer, it's based on a calculation. The calculation is mathematically, it's a true or a false. That's it. You can't come up with anything else. So that's the way the trust is based on. That's a lot of people saying, well, you trust it. Okay. And that's why it's decentralized, means lots of people are doing this for you. Immutable means that the blockchain is tamper-proof. In other words, when you put a transaction out there, when you send Bob to Alice 15 Bitcoins, it doesn't get tampered with on the way, and it doesn't become Bob to Fred 15 Bitcoins. And I'll show you how that is done. We'll do a little practical example so that you can really understand this, because this is thing called hashing is the way that you can ensure there is no tampering. And once you understand this idea of hashing, I think that will be move you a long way forward into understanding blockchain technology. So it's a very key aspect to learn. And transparent, we just covered that we said that the open ledger, we normally would be using Bitcoin wallet addresses. So although everything is in the clear, you don't really know who that person is because it's just a gobbledygook a string of 32 characters that are displayed in the public records. Okay, so let's see what happens next. So this is the definition of blockchain, and what we'll do is that I'll go through the definition, read it out, and then we'll expand on those terms as we go through in this discussion. So blockchain is, in the simplest term, a time-stamped series of immutable records of data that is managed by a cluster of computers not owned by any single entity. Each of these blocks of data is secured and bound to each other using cryptographic principles, i.e. the chain. It's a database. So in conventional world, when we talk about databases, let's say you keep a name and address type of, like a CRM, where you store people's names, addresses, phone numbers. You can go back in and edit those records. So if the guy changes their phone number, you go and edit the record, or if they no longer exist, you delete that record. The big difference is the blockchain is a database. It's a database of transaction records. But the big difference is you can only add records. Once that record is entered into the blockchain, you cannot delete it, you cannot modify it, and you cannot do any changes whatsoever on that. So it's there for life, basically. And that's one of the key elements of trust in this kind of a network. So in a cryptocurrency like Bitcoin uses the blockchain as a decentralized, distributed public digital ledger that records all the transactions of the Bitcoin. And the blockchain network hence has no central authority. You said it's a group of nodes, computer nodes. Since it's shared and using an immutable ledger, the information in it is open for anyone and everyone to see. Hence, anything that is built on the blockchain is by very nature transparent, and everyone involved in is accountable for this. The blockchain has a unique feature of storing the value of previous block as a hash value in the current block, which makes it impossible to alter any blocks without changing all the subsequent blocks. So that last one I need to explain a bit. So we've said that a block generally is all the transactions that are being grouped together in Bitcoin world, it's 10 minutes. So all the transactions that took place collectively are put in one block. And when you've completed that block, you have to create another block after that. And that block, the new block, is linked to this previous block by some linkage mechanism, which ensures that it's like a sequence number. If somebody changes that sequence number, you know that it's not correct. It doesn't follow on. So, think of it like when you go to a store and you have to pick up a ticket, all right? So, those roll-out paper tickets. So, your place in the queue because you've got a ticket number. And that, if you're number 21, that you're the next one after the 20 has been serviced, right? So it's kind of like that. So blockchain just maintains this list, a linked list that ensures that nothing gets jumbled around and that all the transactions are accounted for. So in Bitcoin, what is this thing called mining? So, and mining, when you talk about all these computer nodes that are grouped together to form this blockchain network, think of something like this, or it could be something on a bigger scale. But essentially, it's just like a computer cards in a frame that just does computing. Think of it like a massive calculator. So all it does is calculations, and they have to do work really, really fast. And so when you buy, if you were to buy a mining rig, that's all it does. That the faster the processing is, the better your chance of making money using Bitcoin mining. And the word mining is just like the old, think about gold mining when, people used to go and, crack rocks everywhere and pan for everything. And, you might get one nugget of gold after you sifted through a ton of, rocks before you get the one little, speckle of gold out of it. So mining in Bitcoin world is similar a thing that you have to put a lot of effort in to get some money out of this thing. And the way to help you is, just like in mining, you'd have instead of having a spade, you might get a forklift or some, excavator or something to make your work faster and quicker. So in this Bitcoin world, you would use larger and larger computers. And the reason why it's an open frame is that this thing is calculating like crazy, and it just generates so much heat. And so you never really see them as closed. So if you don't have any heating, this is the way to keep your house warm and earn some money at the same time. Okay, so mining is really just an operation where you calculating these things called hash values for the blocks and validating those transactions in a block. When you do this calculation, you get rewarded and you get a little bit of a fee for doing that. So what is this mining thing, right? So there are about 7,000 or more computers in this blockchain network currently, and they all do the same thing. The mining process of Bitcoin is this thing called the proof of work. And the proof of work is really a puzzle that this miner has to solve. And this puzzle, if you solve that puzzle and you're the first to do it, you get rewarded for that. Okay, and so once they find a solution to the puzzle, they have the chance to make money and also determine the next block. So every 10 minutes, all transactions are collected into a block. We've said that the way the network handles this puzzle is that they make sure that the puzzle can be solved within 10 minutes. Okay, they don't want to make it too easy, but they don't want to make it too hard. So 10 minutes is the time they allocate to having somebody come up with a solution to that problem. So the miner's job is to find a number. It's called a magic number, such that when this number is used together with the ledger transactions, and you do this thing called a hash, it'll come out with a string of zeros, 30 zeros or whatever, and then the number follows. And this is where the problem is that it's a question of luck, and it's a question also of being able to have a fast machine to do it. So generally, in the blockchain world, you need to do about 1 billion calculations before you come up with the answer. 1 billion calculations. So that's why fast computers are absolutely necessary for this activity. So the first miner to get this number will win the prize, the Bitcoin fee. And the difficulty is set to allow the puzzle to be solved within 10 minutes, as we said. And the thing that is done is this thing called SHA-256, which stands for Secure Hash Algorithm with 256 bits, developed by the NSA in 2002. So it's a security algorithm. Okay, so I know it's a lot to take in right now, but it'll start to come clearer because I'll repeat it in a different way so you have a chance to understand it.
Can I ask a quick question, Nat?
Yeah, please go ahead.
Maybe this is coming up already. Can you go back to that slide you're just on?
That one, yes.
Yeah, so when you say there's 7,000 nodes, so is there essentially 7,000 different instances in a race to validate the block? And
So
one of those 7,000 will win?
Yeah, basically, yeah. I mean, they could be anywhere in the world. I mean, you could have a farm of bit mining, and that could be one node, right? So I don't mean it's just one computer. I mean that you could have a server farm, right? And like some of the big companies, because they may have 100 or 200 of these running all at once, trying to find this magic number. And so the amount of heat that it generates, it forces them to find somewhere where it can be kept cool. They don't want to spend money on electricity trying to keep these things cool. So you'll find that there are server farms out in Iceland
Sure.
almost like igloos where they're running, and being naturally cooled by the environment, right?
Right. So whether a company, runs 100 nodes or 1,000 nodes, maybe they run 1,000 to increase their chances, there is only a single node that will win the race. Is that correct?
No, it's not a single node that will, it's the first node to count to find this number. Okay.
Okay,
So
is that not a single node then?
yes, it will be a single node, but it will be the other ones could find it eventually as well,
Right,
right? But
right,
it's a race.
right. So
And
that's sort of my question. There's a single node that will win the race. Is that correct?
correct, yes.
Okay.
So when that single node wins a race, they get the chance to add this value into the block so that everybody can validate it. So the validation process. So when you send it out and say, oh, can you check this transaction is correct? It only takes seconds, okay?
Okay. And
But to
that's the
find the
consensus.
number, to find the number, this magic number that is used for doing the verification, that takes a long time.
Right. And
Once that number is given and you tell everybody, this is the number that I found that works. And if once everybody starts using it, it only takes seconds to, or microseconds to actually do a verification. All right. So
right. And
you have to distinguish.
that's the
That's the
consensus
distinct.
part, right?
Yeah, so the
The
consensus is
validating.
done by verification and validation, but they have to have this magic number to work with in the first place.
Right.
But so the person who gets the magic number is really, that's the key thing that is shared with everybody in the next stage of the validation process.
Right. So if you were operating a node to mine Bitcoin, but say you weren't doing it very efficiently, it's entirely possible you would never win that race.
Absolutely.
Okay. Thanks.
Absolutely. Because as you said, I'll show you that you need to do about a billion calculations within that 10 minutes. And so, it's the people who have the biggest power, or, the largest computers are at their disposal, are going to have a chance, right? So is that clear, Greg? Okay, great. So this is a diagrammatic representation, a little bit more detailed of how the process of doing this calculation and creating a hash. So every now and then, don't worry too much about it, but every now and then, the puzzle complexity is handled by this thing here in black, and it just says, what they do is they try to keep the control so that it allows you up to about 10 minutes to get that calculation done. And what they generally do is, this hash has 256 bits, and what they talk about is that find a number such that there's certain number of zeros in the beginning, and the rest of the digits are used to make this magic number. So when you do this calculation, always there'll be, say, 30 zeros leading in this number. And that is the hard thing, because you have to go through so many calculations. I'll show you in coming up this idea. So this is just that in the peer-to-peer network, every node is seen as part of this network. So they all get a copy of this ledger and the ability to calculate the next hash value or the magic number. So everybody takes part in this. So nobody is more superior to another at this in this side of a network. So here's this thing, what they call the proof of work. So you see this number. So let's say on the left is the ledger, right? So you've got a record of transactions. Alice pays Bob, Alice pays you, Charles pays you. All these transactions are in that ledger. And then your task as a Bitcoin miner is to find that number, that 107376543 is the magic number, okay? How to arrive at that number, the person had to do this. You see the probability of finding a number, which in the right-hand side is the result you want to get. You want to get these zeros in yellow, 30 of them, right at the beginning. And to get 30 zeros and then everything following to once you run this SHA 256, it takes 1/2 to the 30th, which is 1 billion transactions. So every time you ask for another zero to be added, it doubles the amount of effort needed. So that's just the consequence of using binary numbers, right? So right now it's 30 zeros, but it could, the puzzle could be changed so that it says I want 60 zeros in front before I get an answer. And so, and so what's happening is the Bitcoin miner has to keep trudging through. It's a bit of luck and a bit of, so if you hit so it's almost like lottery. So you keep trying on this number and when the puzzle, you'll know you solve the puzzle when you see, oh, suddenly I've got 30 zeros in front and then there's all these other string of digits after. Now you solve the puzzle, you publish that to your network and let them know that I've solved the puzzle, I'm the first one, and you try this and validate the next block of transactions with this, right? Any questions on that? Okay, I'll just move on to the next bit. So we talked about the fact that, these there's blocks and we talked, but we haven't covered the chain, the block and the chain. They're linked, they're things that have to go together. So in the network, we have this thing where we have some linkage, and the linkage is a thing called the previous hash. So every block has this hash number in there. And in the next block, you have a record, you have some data in there that has that value. So if the value doesn't match up with the previous one, there's something's out of sequence or it's incorrect or something. So the block is chained to the previous block. Okay, so you carry on doing this chaining process as each new block is added to the blockchain network. Okay, so that's how you maintain a permanent ledger that keeps growing and growing, but with records that are always have been validated and can ensure that the history is maintained throughout as a permanent record of transactions. So I'm going to just, here's a chance for everybody to be interactive, okay? So I've created this little game, if you like. So we're going to create a hash algorithm. And the hash algorithm is basically, let's take the letters A to Z, and we allocate a number to each letter, just so A is 1, B is 2, etc., and Z is 26, okay? So what we want to do is, when we're using letters, we just want to convert them into numbers so we can do a calculation afterwards. So Bob, the word Bob is, as you can see, it takes the word, the B is letter as number 2. O is, if you look along there on the bottom, it says 15, and then 2 again for B. So when you add that number together, the value that we coded is 19. And that's just a way of, bunching that word Bob together. So if we do the same for Alice now, and go through and use that table, we come up with the value of 30 to represent Alice. So if we want to send a message in the blockchain where Bob sends Alice 15 tokens, we need to send this thing called a hash. And you'll see why the hash is important. But right now, let's say you want to send this hash value. You have to calculate that. So what we do is you need to calculate by adding the value of the coded value for Bob, which was not on the bottom row, you'll see 19. The coded value for Alice is 30. And the coded value for the amount, we just leave as it is 15. So when you add it together, 64 is really what we see as what they call the hash, our simple way of saying hash. So if we send a message with Bob, Alice, 15, and 64, that message is now kind of immutable. In other words, it can't be changed without somebody knowing that's the problem. And when you send a message, the other side of the network also has this table. So they're also able to perform this calculation. So when they do this calculation with the message and it doesn't come to 64, they know that message has been tampered with, okay? So we'll do an example and hopefully you can see clearly that how a tampered message will look. Okay, so again, I've just taken the first half of that hash algorithm. So because we're only using a few letters there. So Alice, Bob, and Dan we're only concerned with 3 people. Instead of using the whole word Alice and Bob and Dan, I just call it A, B, and D for easy calculation. So we said that to send money from Alice to Bob and 15 Bitcoins, we would send a message AB15, as you can see. And AB15, if you code that, it comes out to be 18. A is 1, B is 2, and 15. So add that together, it becomes 18, right? So if you send AB15 and this hash value that we just calculated as 18, you know the message is good. When at the other end, because when I receive AB15, I ignore the hash and I recalculate it myself because I have that same table and it comes to the same value, 18. Okay, so I know that message is good. Now, let's say, for example, the message has been tampered with and we send DB25 and this 18 number still goes with the message, but when you calculate DB25, it comes to 4 plus 2 plus 25, it comes to 31. Hey, hang on, that doesn't come, it's not the same as 18. So can you see here that you now have a way of ensuring that the message integrity is intact? It has been tampered with in this case, but in the previous case, that message was valid, okay? Does everybody see that? Okay, so this is a very, very simplified way of how hashing works. Hashing is just a way to ensure that messages don't get tampered and you lose integrity and trust in that message. So by having hash values, that's what the whole Bitcoin world and blockchain is about. It's calculating hash values such that when you do the calculation on your node and it comes to the same figure as what everybody else gets, you can trust that transaction and you can trust that it hasn't been tampered with, okay? So that's kind of what we've are able to do with hashing. And it's a very, very key piece of knowledge that you need to be aware of. So now we're just going back to kind of understand how transactions are done. So we said that when you have a block, you need to verify that the transactions within that block are valid. So what we said is that we're going to use hash values to ensure that. And when we bundle the transactions into a block and calculate this hash, when we put that into the block and send that block, everybody in the network, in the blockchain network, gets the same transmission. So they get a copy of that transmission. And they can do that calculation just like we did in the example and do the calculation on their own and verify that that number agrees with the hash value that they got. and if it's okay, then it's almost like thumbs up. Yes, this is good, and the transaction is now put onto the ledger as being a valid transaction. So this other aspect, solving the proof of work algorithm, that's the area that we said that is the most complex part for the miners. So when you add a new block to the blockchain, everybody in the network will get that block. Okay. So let's just move down one. Oops. Oh, and basically, this was just to show. I think we covered it in a way, but we said that when we do transaction, we normally say sender, receiver, and the amount. And we said because it's in the open, you don't really want to have your name out in the open, but you would use your wallet address. So I'd just say we called it XXX for Alice, and YYY for Bob, and ZZZ for Dan. So when we put the transaction in the open, as we see below, your privacy is maintained, but it's still in the open, so everybody can still see it, although they don't know who XXX and YYY is at that point. So now I wanted to go back and touch on smart contracts. So smart contract is a protocol intended to facilitate, verify, and enforce the negotiation or performance of a contract. So this, in the business world, this is going to be a very key aspect, and that's where a lot of the companies who are working on blockchain technology are focused in. So contracts should be converted to computer code, stored and replicated on the system, and supervised by the network of computers that run the blockchain. So let's say when you do contracts, you have to have some kind of terms and agreements that somebody has to sign off on, and then ensure that the contract has been executed as intended. So if there's a failure in the contract, if any point, there has to be some consequences. So coding that you use in the blockchain network can take care of the eventualities and criteria that are met during that execution of that contract. It's all pretty much done automatically, and that's a very good attraction for having smart contracts. So smart contracts can be used for all sorts of situations that range from financial derivatives, insurance premiums, breach of contracts, property law, credit enforcement, financial services, legal process, and crowdfunding agreement. So you can see that smart contracts are going to hit all areas of business, and so it's going to hit it in a big way. Going back to the beginning where we said the tipping point is about to happen, these are the reasons, right? When you think that the lawyers who charge you, ridiculous fees for getting things done, and when you can use smart contracts, imagine the cost savings there will be when smart contracts become available for a multitude of legal contracts. Okay, so there's big savings to be had in that area. Similarly, for real estate, just think about the process and how much commissions that realtors earn just because they're handling the contracts and negotiations on behalf of the parties of buyer and seller. So that's a big thing. And so not only is it just in that area, but there's also a thing called supply chain management, right? Where let's say you are running a restaurant and you have to build a burger, right? You need to know and trace back to what are the things you needed to make the burger, lettuce, bread, your buns, your meat patty, your mayonnaise, all that kind of stuff. And so if you're tracking how that burger is built and how it's how it generates profit, and having traceability in terms of, is there one element in there that I'm using too much of, and can I make cost savings here and there? these things can be handled through the supply chain management using this aspect of smart contracts. So you can see all walks of life and business are kind of open to having some kind of blockchain technology integrated into that system. Okay. So I think this drawing now is kind of right just to put everything together in one place. So hopefully you can see now how it's grouped together, going over some of the concepts we went through. So when you want to do a transaction, we start at the beginning on the top left, and you go, somebody does a transaction. So they push that transaction into the peer-to-peer network, or the blockchain itself, where we said there's thousands of computers, or we call them nodes in that terminology. So everybody has a copy of this transaction request. And then each of the node will go through this hashing process to calculate and validate it. So if they all reach the same answer independently, and you have more than 51%, we've said, that means that transaction is valid, okay? And then that transaction, once we know it's valid, the information goes into the public ledger as a block. And then that block, we finally put that in the chain of other blocks. So now we have a whole sequence and a historical record of all the transactions. So they all become, part of this blockchain. And so in the end, that transaction is complete, and we now have our transfer completed and recorded in the public ledger. So that's how that whole process works. I know it went through in like a whirlwind fashion, but I'd like to kind of get some feedback as to how many people I've lost, and if there was any burning questions that I may be able to answer. So open to you, please.
Nat, that was awesome. I've initially learned about it about maybe 10 years ago, but I didn't stay following it. But you've really put it together in a way that just helps make sense of it a bit better. My question is, so we should think about blockchain and cryptocurrency as kind of a medium where transactions go through. Is that correct?
Okay, so remember that the blockchain is a vehicle for making transfers of value, okay? So the key word is value. So what you're doing is you're transferring value from A to B. Bitcoin is just one facet of value. So Bitcoin is like a small subset. Cryptocurrencies are just one aspect of something that's transferred of value. So Bitcoins have value, so you transfer from A to B. That's what you transferred, okay? So when it's smart contracts, the thing of value is the contract itself, right? That's what you're transferring between yourself and another party to complete the smart contract process, okay? So when you're talking about, like we said, supply chain management, like a car leaving the factory, going to the dealership, from the dealership to the owner, you're transferring something of value and keeping a record, a permanent record of that. So the VIN number is the tracking number for that particular asset, okay? So that's what we're doing. So the blockchain is a mechanism for transferring values between two parties or two or more. Is that made it clear?
Yes, thank you.
Okay. Anybody else, please? Well, if there's
Thank
no
you,
other
Nat.
yeah.
That was amazing.
Okay.
My mom's probably told me this stuff a bazillion times, and honestly, it never sticks for me. But it's such a cool thing,
yeah.
and it's really laid out nicely here, and I'm so glad we recorded this so I can at least go back and go over it when I need to.
Yeah, probably your mom will have a few things to say about that. But
I'm sure she'll watch it anyway.
yeah, okay, that's great. So yeah,
Yeah.
if there's anything else, if there's no more comments or anybody wants to ask me a question, feel free, if you're here, just to come and tap me on my shoulders, and I'll certainly help. Okay.
Awesome. Thank you so much, Nat. Thank you
Thank
so
you
much.
so much. Thank you.
Josette
Thank you,
and
guys.
Jason,
Thank
for
you.
everybody coming out.
Yeah.
I'll have an amazing weekend.
Yeah.
We'll talk soon.
Thank you so much. Take care.
Thank you, Erin, for organizing, and thank you so much.
Everyone.
No
Bye-bye.
problem. Bye.
Bye.